record on this computer. Here we go. So looking at number 2 here, the lowest number that both 5 and 4 go into, okay, if I'm adding my fractions is, I go, well, do they both go into 5? No, 4 doesn't go into 5. Double 5, 10. Do they both go into 10? No, 4 does not go cleanly into it. 15, 5 times 3 is 15. Yeah, it goes into 15, but does 4 go cleanly into 15? No. Lowest number is 20, okay? That's the lowest denominator, okay, that both 4 and 5 multiply cleanly into. So that is what they call the LCD, the lowest common denominator. Now, from here, here's how you do the math, okay? I asked myself, I'm gonna stop my share for a second and just turn everybody's microphone off, if that's okay with you all, just so you guys can hear me. Mute all. Mute all. Yeah, everybody's muted. There we go. Back to my little presentation here. Where was I? I'm down here. Hang on just a second. What did I just do here? There it is. I'm back. Okay, so what's the lowest number that, well, 4 became a 20 here, okay? I got 3/4, and I said they both go into 20, 4 and 5. All right. How did the 4 get to 20? I must have multiplied that by 5, right? To get it to 20. So whatever you do to the bottom number, you have to do the same exact thing to the top number, okay? So 3 times 5 is 15. All right, listen to me talk through the next one here, up above here. 5 became 20, right? What did I multiply it by? I multiplied it by 4, okay? So whatever you do to the bottom, you got to do the same exact thing to the top. And you got to get an 8 here. All right, I am now ready to add, because you see over here how when we had the same denominator on the left, we were ready to add. I got the same denominator now. So I'm going to bring it down 20 here, excuse my scribble here, and I'm going to add my numerators. 18, I'm going to switch this to 18, 19, 23. This becomes 23 over 20. I added 15 plus 8. Okay, those are my numerators, and that's how I got 23. That's an improper fraction. We change it into proper by doing the same thing we did over on the other one. I ask, how many times does 20 go into 23? 1 time. How many are left over? 3. And then I keep the denominator. And the last question I always teach my 60 students is, make sure you can't reduce 3/20. The last question is, can I reduce? Okay. So there's your answer. So I'm going to circle my answers here so that it becomes real clear what the answers are. Here's an example, number 3 here, which you guys have copied down, of 3 different denominators, okay? So what I'm going to ask myself is, what is my lowest common denominator that all 3 of those multiply into cleanly? All right, here's how my brain works. This is how I think. I start with the biggest one, 15, okay? And I ask myself, does 5 go into it? Yes. Does 6 go into it cleanly? No. So I double 15 to 30. Okay, now I just happen to know that is going to be my LCD, because 5 goes into 30 and 6 goes into 30. Okay, there is my lowest common denominator right there. Okay, all 3 of these denominators, 5, 6, and 30, all go into it cleanly. They multiply into it. So again, I'm going to ask myself, 15, how did it become 30? I multiplied by 2, right? So I got to do the same to the top, and I get 8. Listen to this again. This one right here, 2 over 5. How did 5 become 30? I multiplied by 6. So 6 times 2 is 12. 6 up here, 5, 6 is something over 30. How did the 6 become a 30? Times 5, right? 5 times 5 is 25. Now I'm ready to add, because I have the same denominator, and I'm going to add up all my numerators. This is like 20 plus 25 is 45. Just did that real fast in my head there, but that's an improper fraction because the numerator is larger than the denominator. So I divide my denominator, 30 goes into 45. One time, there are 15 left over, and that goes over 30, okay? Now, this is a great example of the last question you should always ask yourself. Did I do that right? 30, 40, yep. Can I reduce this fraction right here? And the answer is yes, because 15 goes into 30, so it becomes 1.5. 15 goes into itself once and into 30 twice. This is actually the final answer, reduced, what they call reduced answer, okay, to what they call lowest terms. All right, that's adding fractions, okay, and it's a fast lesson in adding fractions. The good news is, let me talk about a couple more examples. So I want you to go ahead and copy these. There's two more examples. I want to talk to you about how to add mixed fractions, okay? So you have 4 3/5 plus 6 3/4. Now, I like having you hear how I say these fractions so that you get used to what they sound like if you spoke them. Number 5 has 6 1/2 plus 1 1/3 plus 14 1/4. Okay, that's how you would say them out loud. All right, going to give you another about 5 seconds to finish copying these down. Okay. All right. Now, the first rule I taught you about 15 minutes ago is when you're adding fractions and subtracting fractions, make them vertical, not horizontal like this. So the first thing I would do is change it and go like this on my paper. If I was doing this in a class or in any scenario, and 3/4, okay? Now, I'm going to say if you're adding fractions, put this if on here, I want you to write that. In fact, I want you to literally write this and draw an arrow to it. If you're adding, okay, I'm going to circle it even, okay? If you're adding fractions that are mixed, the next step I highly advise is to add the whole numbers first. 6 and 4 is 10. And the reason, and write it nice and big, okay? And the reason why is because a lot of students will get really busy working on the fractions over here. They'll get an answer and then they'll move on and think that's the final answer. They will forget, and I've done this before, they'll forget to the whole numbers. So that's why I tell my students, if you're adding mixed fractions, you don't have to worry about anything. You can go ahead and just add the whole numbers first, okay? Now, with these fractions here, I'm going to write, you should write this too on your paper because it helps you understand what you're supposed to do here. Equals, okay? Look at these two denominators again. And the lowest one they both go into is 20. I know that because I have my times tables. Now, if you're thinking tonight, I have no idea how we got 20, that probably means you don't know your times tables in your head. And you really need to learn those. Like right now, get an app for your phone, start learning one number at a time. Got to have that because otherwise you're going to be lost in all math after this, okay, including this. All right, how did the 4 become a 20? I must have multiplied it by 5. That means I multiply it 3 times 5 and I get 15. How did the 5 get to 20? I must have multiplied it times a 4. So I do the same to my numerator and I get 12. I have the same denominator now. I'm ready to add. So there's my denominator. And 15 plus 12 is 30 minus 2 is 27, okay? Now this gets a little bit tricky here. I want you to pay close attention to this. Do you see I have an improper fraction again? I have a bigger numerator, number on top. Then I have a Dino. Dino's a guy that always gets pinned, so he's on the bottom, all right? And so I'm going to convert that into a mixed fraction. 20 goes into 27 one time. There are 7 left over 20. Now, this is where a lot of students would just go on to the next problem. And this is why I warned you. Look at this over here. They forgot that. If I add that 10 to the 1, I get 11. Final answer, 11 and 7/20. Can I subtract 7 over 20? No, I can't. I mean, sorry. Can I reduce it? No, it won't reduce. Okay, I'm going to do this next one faster because for the sake of time. Because of this, I'm going to add my whole numbers. 14 and 6 is 20 plus 1 is 21. I'm going to look at all of my denominators here. It's going to get a little bit tight for space here, okay? 3, 4, and 2. And I know, because I know my times tables, all of them go into 12. That's the lowest number they all go into. And 4 times 3 is 12, so 3 times 1 is 3. 3 times 4 is 12, so 4 times 1 is 4. And 2 times 6, so this is a 6. I'm going to add everything, bring down my denominator. 3 and 4 is 7 plus 6 is 13. Again, I have an improper fraction. 12 goes in it once. There's 1 left over, and a 12. It's a good thing I did my whole number first because I got a big 21 hanging out over here. I add it to my 1 and 1/12. That equals 22 and 1/12. Okay, that's adding fractions. All right, I'm going to stop here for a second and look at you and go off there. And if you guys don't mind turning off your camera, that would be excellent, just so everybody is kind of anonymous on my recording. Appreciate it if you could all just turn off your camera. Thank you. Appreciate that. Just hit that camera and turn it off there. Now let me see if I can. Yeah. Okay. Thank you, guys. Are there any questions about the adding fractions? You can speak in your microphone if you like. You can turn it back on, or you're welcome to put it in the chat as well. Okay, I'm going to go on, and here I go. I'm going to talk about subtracting fractions. Now, the nice thing about subtracting fractions is that it's the same exact process. So I'm going to go through this a little bit faster, okay? In fact, quite a bit faster. Make it vertical, and always put the smaller fraction underneath if they ask you to be subtracting fractions in this class, okay? So I've got 5/9 minus 2/9, okay? If you have the same denominator, you can just start subtracting. Bring down the denominator and subtract the 2 from this numerator, this up here, and that gives me 3. Here's a good example of my last question should always be, can I reduce, okay? Yeah, in this case, I see that 3 goes into both. So 3 goes into itself once, and it goes into 9 thrice, 3 times. That's my final answer, reduced, okay? All right, next one, 5/6 minus 1/3. All right, I have different denominators. So first thing I'm going to do is write my equal sign. I'm going to ask myself, what's the lowest number that both 6 and 3 go into? Well, they happen to both go into 6. Okay, now if you were thinking 12 or something like that, look, don't forget that maybe the biggest of the two is a number they both go into. And 3 times 2 is 6, so this becomes a 2. 6 times 1 is 6, so 5 times 1 is 5. Now I'm going to bring down my denominator because it's the same here now. I've got the same denominator here, and I'm going to subtract my numerators. 2 from 5 is 3. Look at this. That needs to be reduced because 3 goes into both of those, so that becomes 1/2. Okay, so that's my reduced final answer to that problem. All right. Now I'm going to do this one over here on the right, number 3, which is 9 5/7. And I want again to have you hear me saying that, so your brain starts saying it like that in your mind, minus 3 1/2. All right. Because I'm subtracting here, I got to kind of make sure that this fraction over here is smaller than the one above it. And it is. 5/7 is more than half a 7, so 1/2 is a half. 5/7 is more than a half, so I can subtract. Now you might be asking yourself, why is that important? Look at this. If I said, I want you to go like this, 5 minus 7, or let's take 25 minus 7, okay? You learned back in the day that when you're subtracting and you got a smaller number on top, you got to borrow. You would borrow, make that a 1 and bring over the 1 here. And that's how you would do this, okay? And this would be like 18. All right. Now, the same is true when you're subtracting fractions, okay? And that's why you got to ask yourself, if I'm subtracting, is my top fraction bigger than my bottom one? Is it greater than? It is in this case. So because it is, I don't have to borrow. I'm going to pause there, okay? Because the top fraction is larger than the bottom one, I don't have to borrow. So at this point, I can subtract and get a 6. 3 from 9 is a 6 right here. Notice again how big I made that. All right. Now I need a common denominator, which I taught you how to do. I look at these two denominators, 7 and 2, and I ask myself, what's the lowest number they both go into? It's 14. How did I know that? Because I know my times tables, okay? I know 7 times 2 is 14. 2 times 7 got me 14, so 1 times 7 is 7. 7 times 2 is 14, so 2 times 5 is 10. I'm now going to bring down my 14. This is a lot of steps, isn't it, guys? I'm going to subtract 7 from 10. Those are my numerators. You get a 3. And I'm going to look at this and ask, can I reduce it? No. Final answer is 6 3/14. Okay. Again, I want to repeat to you, if this is like brand new to you or it's been so long that you just don't remember any of this, I apologize because technically you're in a class above what you should be in. However, I still don't think you should quit and move down. You might still be fine here because this is only one module out of 10. And even if you don't do so well on this one, there's 9 others, you can still pass my class, okay? And again, why? Why would that be important to me? Because I teach the next class up and you get to use a calculator anyway. All right. I want to talk to you about how to subtract and borrow. So if you want to write that down in your notes, subtracting and borrowing. I'm going to give you about 10 seconds here to copy this down. How are we doing for time? We're doing okay. It's going to be a little rushed. Well, I think we'll make it. Okay. And 10. Okay. So I'm subtracting. Okay, I see this minus sign here. And I told you that when we're subtracting, we got to look at our fractions and ask ourselves, is the top fraction greater than the bottom? Okay. Well, this is a good example. You can see that 1/3 of a pie or a pizza is less than 3/4 of it, or 1/3 of a dollar is less than 75 cents. Okay. So I got to borrow. This is where there's some steps here. So I want you to follow this carefully. And that's part of why I'm recording this. And there are also Khan Academy videos in my course waiting for you to watch that show this. I'm going to cross out the 8 just like I would do when I'm normally borrowing. I'm going to make it a 7. All right. I'm going to bring 1 over. But watch this. Watch what I'm going to do here. I'm going to add the version of 1 that I'm going to bring over is going to be 3/3. Now, some of you know why. Some of you are asking, why did he pick 3/3? I'm going to show you over here. Any number on top of itself equals 1. It's the same thing as 1. Why? Because 2 goes into 2 one time, okay? 5/5 is the same as 1. It equals 1. Any number on top of itself is 1, okay? So the reason I chose this 3/3 version of 1, you hear that word version? It's the version of 1. Is because I got a denominator right here that's a 3, and I'm supposed to add something to it. And if I have the same same denominator, I can add. That's why I picked 3/3. Okay. Now, here's what you would do next. I would write my equal sign. I'm going to do the math horizontally here. Okay, I'm going to go 1 plus 3 is 4. And well, what's going on with that pencil? All right. And then 3, this is my deno here, my denominator. So I'm going to keep it the same. That's 4/3. I just tell my students to slide this over here, minus 3/4. Okay. I just slid it over. Now I can start working on the fractions because I have a bigger denominator. I mean, my fraction on top is greater than the one on bottom. All right. In this case, I'll go a little bit quickly now. My denominators, 3 and 4, my bottom numbers here, the lowest number they both go into, again, in this case, is 12. We've had a couple like this, okay? And again, I wrote equals here. 4 times 3 gives me 12, so 3 times 3 is 9. And 3 times 4 gives me 12, so 4 times 4 is 16. I'm going to subtract. I have the same denominator, so I can bring it down. 9 from 16 is 7. Now I'm going to ask myself, can I reduce this? Okay. I can't, but this is where it's so important. Look back over here. Okay, look back over here. I need to make sure I subtract my whole numbers. 4 from 7 is 3. I'm going to bring that over here, and that is my final answer. Okay. That's how I would do that. Okay. I'm going to do one more a lot faster, but so here's what I do. I see that I'm subtracting. This is when my brain works. Okay, I ask myself, is the fraction on top greater than the one on bottom? It's not. 2/9 is less than. Means I'm going to have to borrow. Okay, I'm going to make a suggestion here. Cross out the 8, make it a 7. I would do that next. I would subtract 4 from 7 and make a nice big 3 here so I don't forget it. Okay, now I'm bringing over a 1. The version of 1 I'm going to bring over here to borrow, to add, and actually this should be, I shouldn't have written this here. That should be a plus sign here, so I'm going to erase that, okay? Sorry. If I can get my marker to work, yes, it'll work, won't it? Good. All right, I'm going to add to 2/9, I'm going to bring over 1 that I'm borrowing from this 8 here, okay? And the version of 1 I'm going to choose is 9/9 because of this 9 right here. I need the same denominator. So that's the version of 1 I'm going to bring over. 2 plus 9 gives me 11. And this is the same denominator. This is my denominator, so I'm going to bring it down. Minus 5/9. I'm now ready to start subtracting because I have the same denominator, common denominator. So 5 from 11 is 6, right? That's 6. That's right. All right, I can see already I'm going to have to reduce, okay? Here's my 3 that I'm going to bring over here. 3 6/9 equals 3, and 3 goes into both my numerator and denominator. 3 goes into 6 twice. 3 goes into 9 3 times. That's my final answer. That's subtracting and borrowing. All right. Now, if you're going, man, teacher, that's a lot of steps. Really going to do it? That's like, does it just get harder after this? Here's the answer is, let me go back. I'm sorry, you're going to be distracted. The answer is, this is the hardest type of problem in fractions. There are more steps in that than there are in a lot of your first year algebra stuff. Okay. So, but that is how to do it. Okay. Now, the next thing I want you to do for the sake of time is I want you to take your phone if you have one with you, and I want you to take a picture of this slide. If you don't have a phone, these are keywords and story problems. I'll try to share this with you at the end, actually. Let's see. These are keywords that you're going to run into with story problems. And let me see what happens if I do. I'm putting your all your emails in there. Send. Now I tried again. Hopefully that'll work. You can't share this type of file with because they okay. All right, it might not work, but that's okay. If you could take a picture of that, that'd be great. or if you Googled keywords for story problems, and you'll find this chart, a whole bunch of copies of it, okay? But when you're doing story problems, when you see words like adding or the sum, the total or sum or all together, probably means you're adding. Difference and multiplying and dividing. All right. For the sake of time, I'm going to jump over to my next slideshow here, okay? And I want to talk to you guys about multiplying fractions, okay? How do you multiply fractions? I have good news for you, that multiplying and dividing fractions are actually easier than adding and subtracting them, because you don't have to have the same denominator, okay? So that's the good news, is that it actually doesn't get harder with fractions. It gets easier. In fact, one of my colleagues at the college, George Howard, he teaches multiplying and dividing first before he gets into adding and subtracting of fractions. Okay, having said that, let me grab the pen here. So the first problem here is 1/2 times 3/5, okay? And in this case, the basic principle is that you multiply your top numbers times each other. 1 times 3 is 3, and multiply your bottom numbers times each other. 2 times 5 is 10. And then the last question you ask yourself is, can I reduce? Nope, can't, okay? So there's my final answer. All right, I'll do it again. I've got 5/7 times 2/9. I'm going to look at that and go, yeah, nothing really goes into each other to reduce it or anything. So 5 times 2 is 10. I'm multiplying the top numbers. 7 times 9 is 63. Okay. And I ask myself, can I reduce? I don't think I can. Final answer. Okay. That's the basic principle, is you're multiplying across. Okay. That's what you're doing when you're multiplying fractions. Now, I want to talk to you a little bit about what do you do if you have one like this, where you got 3 different fractions. Okay, what do you do there? What you do is you multiply the first 2. So 3 times 1 here is 3. And you take that answer, 3, and you multiply it by the next fraction, top number. 3 times 3 is 9. This becomes a 9. Okay. Then you got my denominators, my bottom number. 5 times 2 is 10, times 4 is 40. And the last question I ask myself is, can I reduce? 9 does not go cleanly into 40. Nothing goes cleanly into both of them. There's my final answer. Okay. So that's the very basic form of multiplying fractions. But what happens if you get to ones that are a little bit more complicated? All right. And what I'm going to do is kind of let you copy these down. So go ahead and relax. Go ahead and start copying them. And you can write the label above in your notes, canceling and multiplying. Okay. Things called, some teachers you may have recognized at some point used to call it cross-canceling. Cross-canceling. Okay. So I'm going to just let you guys copy those examples down. Don't copy what I write down here on the board here on the right here. Okay. I bet you're almost there. Give you another 10 seconds to finish copying down the last 1 or 2. I think we're doing okay, guys. I think we're doing okay for time. Okay, I'm going to jump into this thing here now, guys. Now, the first thing I'm going to explain to you is the why, because as a learner, I always like to know when I'm in a classroom, why does this matter? or why are we doing this? If I'm in a business meeting or some kind of a meeting at a job with people and we're around a table or we're having a meeting, I want to know, why are we doing this? What is the purpose? And the big question is why. And I think some of you guys might have gotten fractions better if the teacher would have explained better why we cross cancel instead of just jumping into it, okay? And that, here comes the why over here to the right. All right. What would you do? Let's say you're on a test and you're kind of nervous and you're being timed. You only have so long to get done with the whole test. And you ran into a problem like this one I have on the screen here on the right. You don't need to copy it down, but you had to multiply 25 times 35. Now, I don't know what the answer to that, but what if it was 1,750 here, something? I don't have it in my head. This is hypothetical, okay? And then 115 times 235, and let's say it was 15,025 or something. Yeah, 15,250. Okay, all right. And then it said reduce all your answer to lowest terms. Okay. And you're on this test and you're being timed and you're kind of in a hurry because you're taking your GED test or some kind of a test for college. And you go, I have to reduce this monster over here to lowest terms. That would take me, I don't know how many minutes to figure it out, but it would take me a while. And you'd be going, math sucks. Okay. This is why canceling is your friend. Okay. I want you to look down here at the bottom of the screen here. Look at that problem there. If I multiplied 8 times 14, I get some answer. Then I multiplied that by 6. I'm in the hundreds. I'm going to have 100 and something over 300 and something. Okay. And I have to reduce that. That takes me a lot of time. Okay. So cross canceling is your friend. You do it. Basically what it is you're reducing before you multiply. So when you get to the end, you don't have to reduce. It is your big friend. All right. Some teachers call it cross canceling. And that's probably not a bad idea to add that, okay? Because most of the time when you cancel, you cancel, not always, but most of the times crossways here. So what I look at is can I, if you guys know that if I had 2 over 4, that would reduce down to 1/2, okay? That's how I'd reduce that. Well, I got a 2 and a 4 here I can cross cancel any top number with any bottom number. Not straight across, but any top with a bottom. 2 goes into itself once, and 2 goes into 4 twice. Do you see how I canceled them? I crossed them out. It's really important that you do that. Make that really clear on your paper. Why is that important? Because otherwise you start getting ready to multiply and you get mixed up on what numbers you're multiplying. All right. So now I'm going to just multiply 1 times 3 and get 3, and 5 times 2 and get 10. And then I'm going to ask myself, can I reduce? No, I cannot reduce that anymore. Okay. That got me the answer faster. All right. Look at this one down here, number 2, 4/5 over 1/6. I look at 4 and 6 and I got to ask myself, can I reduce those? Can anything go into both of those? Yes. I'm going to cancel, cross out the 4. 2 goes into it 2 times. Cancel the 6. 2 goes into it 3 times. 2 is the number that goes into both of these. Then 2, you multiply straight across here. 2 times 1 is 2, and 3 times 5 is 15. Can that reduce? No. Final answer. Look at this. All right, here's the way I would do the bottom one here. First thing that jumps out in my brain is I know that 7 goes into itself once, and it goes into 14 twice. Next thing that jumps out of my brain is I see 9 and 6 here, and I know that 3 goes into 9 3 times. 3 goes into 6 twice. Next thing I ask myself, is there anything, can I do anything with the 8 and anything on the top? No, it doesn't look like it. 3 times 1 is 3 times 5 equals 15, gives me my top number. 8 times 2 is 16 times 2 is 32. I ask myself, can I reduce that? No, 2 does not go into 15 cleanly. There's my final answer. Okay, so that's how you, that's why you would do this thing called canceling. When you get bigger numbers that maybe you can reduce them before you multiply, that's what you would do. Okay, all right, I want to show you the next kind of multiplication. mixed numbers, right? So I'm going to give you guys 60 seconds to write down. That gives you about 15 seconds per question to write down. That's plenty of time. I have students who are either arriving early or I'll let them in, but in a minute here, I'm going to stop doing that. Or late, either early or late. Okay, that's 60 seconds. All right, having said that, let me talk to you guys a little bit about this. Mixed fractions, you can't multiply them until you change them into something that's what's called an improper fraction. So look over here, I've got number one, I've got 4.5. What I'm going to do is I'm going to multiply the bottom number times the whole number, and that gives me 8. And I'm going to add the top number, the numerator. That gives me 9. So this becomes 9 over 2, okay, times 5 over 6. Okay, so like if I had 1.5, 1.5 here, okay, to convert that to an improper fraction, I would multiply 2 times 1 is 2, and I would add the numerator as 3. This becomes 3 over 2. If I had 4 2/3, I would have to turn that into an improper fraction. 4 times 3 is 12 plus 2 is 14 over 3. Okay, that's how you do that. Okay. All right. Having said that, I have converted it. Now I can multiply. I ask myself, can I cross cancel anything here? Oh yeah. 3 goes into this twice. 3 goes into 3. 9 3 times. Make sure you cancel so you don't forget what to multiply. 3 times 5 is 15 and 2 times 2 is 4. That answer is improper. Changing it to a mixed, you divide 4 into 15, it goes into it 3 times. That's what you do. You see how you have a bigger denominator than your numerator? Got to change. You can convert it into a mixed fraction by asking 4 goes into 15 3 times, because 3 times 4 is 12. The difference between 12 and 15 is 3, and this becomes a 4. Okay, so that's converting improper into a mixed fraction. All right, number 2 here. I got a mixed fraction. I'm going to change. I'm going to go 2 times 1 is 2 plus 1 is 3 over 2 times 1 over 4. I ask myself, can I cross cancel? No. And I get 3 over 8. Okay, that's if when I multiply this times this, I get 3. This times that gives me 8. The next problem, number 3, I'm going to bring over my 2/7. Don't have to do anything with that. Times. Then I'm going to convert this. This is a mixed fraction. I'm going to convert it to improper by 8 times 2 is 16 plus 5 is 17, 18, 19, 20, 21. Oh, this is nice. 21 over 8. Why is this nice? Because I get to cancel twice here. 7 goes into itself once. It goes into 21 3 times. 2 goes into itself once, and 2 goes into 8 4 times. Multiply straight across and get 3 over 4. Final answer. Okay. All right. I'm going to jump on for the sake of time. I want to make sure I don't run out of time. Other ones are the same idea. Okay. It's the same idea of converting it to improper. Let's talk about dividing fractions in the last 8 minutes of class here. Okay. When you divide fractions by hand, the rule is that you invert or reverse the fraction to the right of the division sign, and then you multiply them. That's the rule. Okay, it's very similar to just multiplying fractions. It's the same idea, but you got to take the number on the right, flip it upside down, okay? There's a math term here called the reciprocal. The reciprocal means the reverse. Instead of having 1 over 2, if I did the reciprocal, you would say 2 over 1. That's the reciprocal. 3/4, the reciprocal of 3/4 equals 4 over 3. Okay, so when you do division of fractions, you're going to go like this. You take this second fraction and you flip it upside down. So I would write it like this: 1/2 divided by 1/8 equals 1/2 times the reciprocal of the second number, which is going to be 8 over 1. In this case, I can cross cancel. 2 goes into itself once and into this 4 times. And I'm going to get as a final answer 4 over 1, which equals just 4, because 1 goes into 4 times. Okay, that's my final answer there. All right, the next one, give you another example. 3/4 divided by 5/8. I'm dividing again. Okay, I gotta flip this one here upside down. So it equals 3/4 times the reciprocal of 5/8 is this, and these cross cancel, which gives me 6 over 5. That's improper because the numerator is bigger. 5 goes into it once. There's 1 left over 5. All right, that's the idea of dividing fractions. All right. Let me show you a mixed example of a mixed one. Oh, by the way, if you run into either multiplying or dividing fractions, and you get a whole number here, okay, a whole number times a fraction or divided by a fraction, all you need to do is put it over 1. And then it's the same idea. This becomes 3 over 1 times the reverse 4 over 3. And then I do the math, okay? Again, 8 divided by 6/7, I would just put it over 1. This becomes 8 over 1 times 7 over 6, okay? What about 3/4 divided by 2? That's kind of weird because this one's bigger, but there's what I would do. I would put it over 1, and then I would do 3/4 times the reciprocal, which would be 1 over 2. All right, that's how you divide whole fractions, okay? Mixed numbers, just to show you, it's the same idea exactly as, I'm just going to do one here for the sake of time. We got 5 minutes. We're doing fine here, but let's just do this first one here, okay? If I have a mixed number, I'm going to change that mixed first number into an improper. 2 times 2 is 4, plus 1 is 5 over 2. This becomes 5 over 2 times the reciprocal of the second number, which is now going to be 4 over 1. And then I would finish the problem, okay? I want to show you this one, number 4 here real fast because we're almost done. Here's what I would do with that problem. I would change 5 and 2/3. I would go 3 times 5 is 15, plus 2 is 16, 17 over 3 times, now I'm going to do 2 steps at once here, so don't get lost. 9 times 1 is 9, plus 8 is, what is that, 17? That's 17 over, here, I'll just put it over, that's 17 over 9, okay? I'm going to flip it upside down and go 9 over 17. Whoa, this would be pretty, wouldn't it? Look at all the cross canceling I could do. This becomes 1, this becomes 1, this becomes 1, this becomes 3. Answer is 3 over 1, which is 3. Okay? So yeah, cross canceling and all that is your friend. All right, that is it. That is multiplying, dividing, adding, subtracting, a little bit about how to convert things. All right, I'm going to stop my sharing. I'm going to turn off my recording. Hang on a second. Stop recording.